Okay, so we talked about um, calculating a z-score, and we talked about looking that z-score up on table E to get a probability value. And normally in the world of math, not everything is explicit, and the questions are wrapped in words, right? So this is where stats becomes less numbery and more wordy. And everything you need is in the context of the question. It's just a matter of picking out what it's telling you and what you need from that in order to look it up and get the right answer, okay? So when we're talking about probability, um, again, that's going to be a decimal value that we get from the table. And this, what we're doing now, is a probability of one thing, okay? And we're going to use this earlier formula. If you happen to come across the central limit theorem stuff, that is a probabilities for a group of things. Same concept, slightly different formula, or actually just like a little addition to it. But the premise is all the same. We're given a number to look up. We're given an average or a mean, given the standard deviation. We calculate the z-score. We look the z-score up on the table, and based on what it says in the problem is whether we keep that answer, like a less than, or if we have to subtract that probability from 1 because it's a greater than or an in-betweener, okay? So I think this is going to be labeled lesson 6. Completed notes or other notes are on Canvas, so I'm pretty sure it's day 5 listed on Canvas. And you know, this isn't review, this is new. Okay. So again, this formula is telling us that we're going to get the value in question minus the mean divided by the standard deviation. Okay. So in this first problem, it says the average amount of student loan debt for an undergraduate degree is $37,172 back in 2018. Assume a normal distribution, which means this is what we're going to do, and a standard deviation of 6,500. If one borrower is selected at random, find the following probabilities. Okay, so we have this information for, you know, I guess our country, and we're getting the probability if we just pick one person at random who has student loan debt, that we find, you know, whatever the case may be. And for part A, that the case is based on this information that their student loan debt will be less than 25,800. Okay, so this is the number it's being asked about. They say average amount. Average, that's another term we use for mean. So the average mean amount is 37,172 and gives us a standard deviation. So it's asking about this value. It gives us the mean or the average and the standard deviation. Okay, now one thing to remember is that if the value that you are looking up, right, or given to find information about is less than the mean, your z-score is going to be negative, and that is okay. Your answer for probability, though, is not, okay? So we're going to whip out our handy dandy calculator, and it says step 1, find the z-score. So that's what we're doing here. We're going to find the z-score value. So the top, negative 11372. divided by 6,500. And then rounded. Okay, we're gonna, our table, when we look up our z-scores, goes to 2 decimals, right? So we're gonna round this to 2 places. This 9 is big enough to change that 4 into a 5. So again, this is why our rounding rules are very important. So if you're off a little bit, you might be doing everything correctly, but if you just look at this as 1.74, do all this great math work, and then enter in your answer in the computer, well, it won't like it because it was going to round it. So don't forget to round. All right, so our first step we got negative 1.75 for our z-score. Okay, so we did that. Step 2, find the z-score value in the table, which we learned how to do that before, or in an earlier video. So it's a negative, so we want to make sure you're on the negative side. The first 2 digits are 1.7, so we look here, and then we look to that second place digit of 5. So the z-score value of negative 1.75 relates to the probability of 0.0401. 0.0401. Now, after we do that, this is where it comes into your reading of the problem. So step 3 says, decide if that value, that table E number, is a value that we want. That is the answer, okay? So we keep the value from the table, we keep this number if it is on the left side, right? How do we know if something's on the left side? It says less than. So in this case, since it's a less than value, we got our z-score, we looked up that z-score, this value is the probability of to the left of the bell curve. So this is the answer, yes. Probability equals 0.0401, okay? All right, here it says another question, same data from before, same average, same standard deviation, but now it's asking about a value of 42,000. Okay, so again, step 1, find the z-score for 42,000. So our x, and I'm gonna pause it real quick because I'm getting a phone call, so 1 second. Okay, so not a big pause for you, little pause for me, sorry about that. All right, so we're looking at this question of finding the probability that one person selected at random has a loan debt greater than 42,000. So that is the x value that we're looking at. Same mean, same standard deviation. So now, again, our value, 42,000, is greater than the mean, the average. So we're going to have a positive z-score. Okay. 4828 divided by 6,500. And we get, in this case, when you take that and divide it, this 2 is not big enough to change that 4 into a 5. So our z-score will be 0.74. So we did step 1. Step 2 is we look up that value, and so we look up z at 0.74 on the positive side, 0.7, go over to 4, and we get 0.7704. Now, that's where you want to stop and then go to step 3. Decide if that value is your answer. So if it was a less than, like we did up here, then the value we get that we look up is our answer because it's to the left. However, this one said their loan debt is greater than. So greater than means on the right side of the bell curve. So if we need the right side of the bell curve, we need the leftover probability. So this is where we need to subtract this from 1, or get the complement. 2,296. Okay. So thinking about these two situations, if we think about what this is asking us here, this is telling us that's about 4%. The probability of selecting someone whose loan debt is less than 25,800 is about 4%. Not a whole, not a very big probability. The probability of selecting one person and that their student loan debt is greater than 42,000 is almost 23%. Okay, so this has a higher probability of occurring. And then in context, you want to think about better, right? Is it better to have more student loan debt than the average or less? I hope to God you say less. So less in this case is better. Can't write is better. Or they have a better relative position. So I would prefer to have less student loan debt than more. Yet that does not seem to be happening in my life right now. Okay. So we are going to do number 2. It has a new, we already did that, a new set of numbers, a new data set. It says here each American uses an average of 650 pounds of paper in a year. That's a couple years ago, so might be less. Suppose that the distribution is normal with a population standard deviation of 153.5 pounds. Find the probability that a randomly selected American uses, and then they give us the scenarios. So here, the first one says, is asking for the probability that one American uses more than 800 pounds. All right, so this is what it's asking about. So it's asking about 800. It tells us that the average or the mean is 650 and gives us the standard deviation. I think that's 150. Is that right? Hopefully it is. Yes. All right. So top is 150. We divide that by the bottom. And here, again, we go out 2 spaces for z-scores. This 7 is big enough to change that into 0.98. Okay. So that's our z-score. That's not the answer. We have to look up our z-score. That was me moving the paper. I didn't make, whatever you heard, that was, swear to God, the paper moving. Okay. So we look up 0.98 in our table, and we get 0.8365. Now, we have to decide, is that the probability answer that we want? And we have to decide that based on what it's asking us, okay? So here it's asking about the probability of more than 800, okay? More than is also another way to say greater than, which is also another way to say to the right of whatever we look up, which means we're going to have to do 1 minus that probability that we looked up. We're going to do 1 minus, oops. So just like up here in part B, it said greater than. That means that we have to look up that z-score and subtract that probability from 1. More than is just another way to say greater than. Same concept. Here, this is asking about less than 400 pounds. So this is our new x. Everything else remains the same. Your z-score, or yeah, your x value is less than the average, so we're going to have a negative z-score. And sorry for my terrible handwriting. And here, this 8 is big enough to change that 2 into a 3. Okay. So we have our z-score value is negative 1.63. And we look that up, negative 1.6. And we get this probability of 0.0516. So z at that, I just forgot what I said. Okay. Context of the question. Is this the probability answer that we want? So here it's asking for the probability that one randomly selected American uses less than 400 pounds. Less than is means to the left, which is the answer we get when we look it up. So less than, no more work. That's the answer. You only subtract your value from 1 if it's a more than or a greater than. Phrased in such a way that that's what you would do. Okay. Here for the last one, it says between. So between 500 and 700 pounds a year. So this gives us 2 x's. Okay. We do not subtract these. What we have to do is find the z-score for 500. Find the z-score for 700. Okay. That's our first step. I'm going to run out of room, aren't I? Okay, and that should be just negative, right? That's and that 7 is big enough to change that second digit into an 8. So our z-score value here is negative 0.98. And then here for 700, we find the z-score for that. And here, this 5 is big enough to change that too. So our z-score will be 0.33. Okay, now what do we do with these two? So we look up z at 8. Look up z at 0.33 in our table. Not to make that big farty noise again. All right, 0.98. We have 0.1635. .33. Look that up. 0.33. 0.6293. And this is what we subtract. Okay, remember it's big minus small. So your answer is always going to be positive. So 0.6293 minus 0.1635. Our answer will be 0.4658. That is a lot of writing, huh? Okay. So again, the probability questions with Z-scores, it's kind of like a question wrapped a little bit in a riddle, not too much of an enigma just yet, but there's a lot of context clues that will help you, or they should guide you into the right direction. So with that being said, we're done with that one, and I will move on to the next.